575, everyone's there?
Yeah, absolutely.
We did the review already, yeah? Okay. So we know how to find our amp, we know how to find our vertical displacement, our horizontal phase shift, and last but not least, period, which then can lead us to our B value. Okay, so that's our A, B, C, and D. So like I said earlier, this lesson is pretty much looking at the graph, and we have to derive the equation, and then from that equation we'll be able to answer a few specific questions. So I told you that there's a situation that happened to me personally, and this is the situation. The nail got caught in the thread of a rotating tire, the tread of a rotating tire at point N in the following sketch. Okay, also some information, the tire has a diameter of 50 centimeters and rotates at 10 revolutions per minute. After 4.5 seconds, the nail touches the ground. So, I was lucky enough to get my tires changed before the snow came. Lucked out, the nail saved me. It's great. Yeah. Alright, so let's look at the situation. If we just read a little bit further, they're telling us it's a sinusoidal or a sine graph. Okay? Sine and cosine functions can be sinusoidal, but specifically this is a graph of sine. Let's just read through the information and see if we can put together what our max and our min is. So it tells us that the tire has a diameter of 50 centimeters. So if we look at the tire, our diameter is equal to 50, so that's from here to here. So the maximum will be 50. Okay, and a tire, typically when they roll, they're going to touch the ground. Hopefully you're not hitting any mad jumps. So we're going to be on 0. I'm just going to trade this marker. A little better. Okay, so we know our max, we know our min. They also tell us that after 4.5 seconds, the nail touches the ground. So that's going to be right here. And the x-axis is time in seconds. So this is the tire. The nail is right here, and as the tire spins, it's going to go through this curve, okay, and it's going to touch the ground at 4.5 seconds. Okay, the last hint they give us is that the tire is going to rotate at 10 revolutions per minute. Now, looking at the x-axis, it's in seconds, so minute is actually 60 seconds. So if we take 60 seconds and divide by 10 revolutions, we get 6. Okay, so for every 6 seconds, we're going to have a revolution. So in other words, that's our period. Okay, so if this is the start of our sine function, we're going to go up, down, back to middle. That will be at 6. That's one period of the graph. Okay, so if you want to label this, this is basically your period here. Alright, so using the information, we have to write an appropriate scale. Now on the y-axis, we figured out our max is 50, our min is 0. We could scale up by 10. Okay, and the difference between 4.5 and 6 is 1.5, so maybe a good scale on the x-axis would be 1.5. Now one thing I'm going to talk about is if I were to extend this graph just a little bit further, we'd be at negative 1.5. So from here to here, that would be 6 seconds, okay, if we go into the negative. So going from here to here, this also has to be 6 seconds. So this will be 10.5. Okay, every period is 6 seconds. So we just have to scale it appropriately so that we get to 10.5, which means we'll go 6, 7.5, up by 1.5 again, gives us 9, and then up again by 1.5, puts us at 10.5. Okay, and you just want to make sure that you're going up by equal increments. Alright, so we have our scale. Now let's go to B. We have to find the equation for the height of the nail as a function of time in the following form. So let's start with our amp. The amp is found by max minus min divided by 2. The max is 50, our min is 0, divide that by 2 and we get 25. That's our A value. Vertical displacement, also using max and min, but this time we'll go max plus the min. Divide by 2. So 50 plus 0 divided by 2, we also get 25. But this is our D value. Okay, we found earlier that our period was equal to 6. Okay, so to figure out the B value, we would go B equals 2 pi divided by our period. So it's going to be 2 pi divided by 6, which gives you pi over 3. And that's equal to your B value. So we have our A, B, and D. Now we just need to find our C. And taking a look at the equation, do you see a T minus C here? No, so that's a hint that there probably isn't a horizontal phase shift. And also if we compare to the base graph of sine, it starts at the origin, rises, falls, comes back to middle. Okay, here we're starting along the y-axis, rises, falls, comes back to middle. Okay, we've started exactly at the center point. That should be at 25. Okay, and we haven't gone left or right. So there's no horizontal phase shift, which means we can just write our equation now. So height as a function of time equals our amp, 25, times sine, times our B value, which is pi over 3, times T, plus our displacement, 25. And I believe I said it yesterday, but I'll say it again. Unless your x-axis has degrees in it, you're always using radians for this. So part C, how far to the nearest tenth of a centimeter is the nail above the ground after 6.5 seconds? We're just going to take our equation and we're going to replace T with 6.5 seconds. So H of 6.5 equals 25 sine pi over 3 times 6.5 plus 25. So we just need to make sure we're in radian mode, calculate that, see what we get. Everyone in radian mode? 25 sine pi over 3
My biggest pet peeve, probably.
times 6.5. What's your biggest pet peeve?
Switching from radian to degree.
I know.
Like, I was doing the homework and get every time.
Don't forget to do it though,
Yeah.
even if it bugs you. Luckily it's only a couple units. Okay, you should get 3.5 and our height is in centimeters.
Sorry. Hold up.
37.5?
Yep.
Anyone not getting that?
That's what I got.
So just to keep in mind when you're plugging this in, the pi over 3 and the 6.5 all need to be enclosed in that set of sign brackets. You got it?
You're literally right.
Now who likes the Ferris wheel here? Terrified?
Oh, yeah, every time.
Puke?
Yep, on a Ferris wheel. Yes, sir.
You puke?
Oh, yeah.
Oh no! Okay, we'll take it easy on this question then. Really?
No.
It's okay.
Alright, just a little history about the Ferris wheel. The first Ferris wheel ever built was created by a bridge builder by the name of George W. Ferris in 1893. Although interesting, Do you think that has anything to do with what we're going to have to solve?
No.
No. What a fun fact for the day. And the diameter of the wheel was approximately 76 meters, and the maximum height of the Ferris wheel was approximately 80 meters. The wheel had 36 wooden carts on the wheel, with each cart able to hold approximately 60 people. The Ferris wheel was introduced to the world at the 1893 World's Fair in Chicago. The illustration shown below is a copy of a photograph of the original wheel. Yeah, it's just amazing.
Some big carts.
If they can hold 60 people each, that's actually pretty impressive.
Yeah.
It's quite the wheel. That's the axle.
Yeah, they can make mad cash off of
What
that.
is the possible diameter of that? The real life one?
Pretty good. So if the wheel rotated every 9 minutes, we're going to use the data in the table to sketch a sinusoidal graph, which represents the height of the car in meters as a function of time in minutes. Okay, and we're going to assume that the car is at its lowest point at t equals 0. Then we're going to draw one complete cycle. So maybe let's start with the table of values. We'll plot these points and then we'll just talk about those points. Okay, so at 0 minutes, we're at a height of 4 meters. So our minutes are along the x-axis and our height in meters is along the y-axis. So at 0 minutes, we're at 4 meters. Okay, at 2.25 minutes, we're at 42. At 4.5, we're at 80. At 6.75 minutes, we're at 42 meters. And lastly, at 9 minutes, we're at 4 meters. So we plotted our ordered pairs. Now we'll sketch our cosine function. Alright, so they're telling us that the wheel has a diameter approximately of 76 meters, but the maximum height is 80. Okay, so our max will be at 80, that's important. And then another piece of information that's important is it says the wheel rotated every 9 minutes. So that would be 1 period. So right away, just from reading this, you know that your period equals 9 minutes. Now I just want to make sure the graph stays up here, so I'll read the question out loud. We just have to figure out the equation, and it's in the form of a cosine function. So let's talk about what we know. Start with our amp. So amp is max minus min divided by 2. Our max is 80. What's our minimum?
4.
Good. So 80 minus 4 divided by 2, we get 38. That's our A value. Okay, let's do our vertical displacement. It's going to be max plus min divided by 2. So this time we have 80 plus 4 divided by 2. So 84 divided by 2, we get 42. That's our D value. Okay, period, we already know, if we look at the cosine function, first I'm just going to draw that over here, let's talk about it. So it typically would start up on the y-axis at its maximum, drop down to a min, and then go back. Okay, that would be 1 period. If I took the reflection of that, we would start down here, we'd go up to its maximum, and then down to its minimum. That's also 1 period. This is pretty much a reflection. Okay, it doesn't have to count as a reflection, but the period would go from here to here. Okay, that's 1 cycle. So if you didn't get it from this information, you could have got it just from the graph. So the period is equal to 9. from that we can solve for our b value. It's going to be 2 pi divided by the period. So we have 2 pi over 9. That's our b value. Okay, and lastly, we need to figure out what is our horizontal phase shift. Now, they're not telling us if it's a reflection or not. Let's just assume that it's going to be the positive version of cosine. If that's the case, normally we would start along the y-axis, but we have shifted right, okay, all the way to 4.5. Okay, when we're at 80, we're at 4.5 minutes. So we're going right 4.5 minutes, which means that our c value is equal to 4.5. So from all this information, we can now write our equation. Okay, y will equal our amp, this is a function of h of t, right? So h of t will equal our amp, which is 38, times cosine. Our b value was 2 pi over 9. Okay, we have a horizontal phase shift of 4.5 right, so t minus 4.5. And then we're going to apply our vertical displacement, 42 meters. Okay, so this is the graph of cosine. So part C, how high to the nearest meter is the cart 5 minutes after the wheel started rotating? So if we're here, 5 minutes, let me just erase this. Okay, we're basically trying to figure out what is the height here. We know x will be 5, what is the height? So what's a good way to solve this? Okay, you could graph this function and then put x equals 5, or you could just replace that t value with 5 and calculate it. So for part C, I'm going to go h of 5 equals 38 cosine 2 pi over 9, 5 minus 4.5 plus 42. And just make sure that the 2 pi over 9 and the 5 minus 4.5 are all in one enclosed brackets for cosine. Okay, typically I would probably put this in brackets, that in brackets, inside of a bigger set of brackets. Alright, so is everyone getting 77.7? So to the nearest meter, we'll have 78 meters. For part D, how many seconds after the wheel starts rotating does the car first reach 10 meters from the ground? Okay, so just off a little bit, shifted. There we go. Okay, so when y is at 10, it's going to intersect the graph first at this point here. So we're trying to figure out what is the x value when y is 10. So the easiest way to do this is to graph your function. Very important, we should already be in radian mode. Okay, let's check our window settings. We can go on the x-axis from, let's go -1 to +10. Scale of 1, and on the y-axis, let's go -1 up to 90, and scale of 10. Okay, and I'm getting those window settings pretty much from our graph here. Okay, y is going up to 90, we have a scale of 10. X is going up to 9, I put it to 10, but the scale is going up by 1. Now we need to put the function into our y equals. So 38 cosine, put in brackets 2 pi over 9, multiplied, close the bracket, and then we have x minus 4.5, double bracket, plus 42. Now our y2 is going to be the 10 meters. When we graph it, we'll see a line go right through. So this is the Ferris wheel, the cart's starting when you load. Now you're almost approaching 80 meters up in the sky, and then you come back down. So we're trying to figure out, after you first load, okay, what would be the time when you first reach 10 meters? So we just have to find our intersection point. Second trace, number 5 for intersect. And typically you don't have to bring your cursor all the way over, but just to be sure, I'll bring it close and go enter, enter, enter. So at 0.81592244 minutes, I'm at 10 meters. If you guys reread part D, it's asking for how many seconds. So for part D, we have a y1, which is our graph. y2 is equal to 10. We intersect these. And you're getting 0.81592244 and 10. So right now this is in minutes. We need to multiply this decimal by 60, and that will put us into seconds. So the easiest way to do that is just quit. Press, well, don't quit, just quit the graph. X, enter. Okay, now we have our decimal showing up, and we can multiply by 60. So 48.9 seconds. If we round to the nearest second, we're at 49 seconds. So just a few things to remember. Whenever we're looking at real life situations, typically your x-axis will be in radians, so you should be in radian mode. And then once you've derived the equation of the graph, like we've done in lessons 7 and 8, then you just have to apply some everyday applications. Okay, so interpreting what that graph actually means. Do you guys have any questions? And that's that, sinusoidal functions. Trig Unit 6, Part 1. Unit 7's Trig Part 2.
How many units do we have?
Left?